Okay, let's work this example. We have a mass, the red mass, that's 2 kilograms, that is 1 meter from the X mark. The mass of the blue ball is 4 kilograms, and it is 2 meters from the X mark. And the mass of the rod is 5 kilograms. And we are asked to find the center of mass of the combination. Now we are going to find it relative to a reference point, that X point, since it is marked for us. Remember the definition of center of mass. X center of mass is the sum of the m's x's over the sum of the m's. Here, since I have three masses, that's going to be m1 x1 plus m2 x2 plus m3 x3 over m1 plus m2 plus m3. Now m1 I'm going to use the red mass, m2 the blue mass, and m3 the rod. So in this case, using this point as my reference point, m1 is 2 kilograms, so that's 2 kilograms, times x1, which is going to be 1 meter, except it is to the left of the X mark, so it's going to be minus 1 meter. We are talking about a position here, so direction is important. It's a vector. Plus m2 is 4 kilograms, but it is to the right of the X point, so it's going to be 4 kilograms times 2 meters. Now the tricky one is the rod. The rod, so what's the position of the rod? From where are we going to measure it? It's very much, we are going to measure it the same way we have measured the balls, the red balls, the red and the blue ball. The blue ball, for example, we measure the distance from the center of the ball to the X mark. The same for the red ball, from the center of the ball to the red mark. We do the same thing for the for the rod. So we have to consider where the center of the rod is. It is 3 meters long, so its center is going to be at about the 1.5 meter mark, which makes its center 0.5 meters to the right of the X mark. So in our case, this is going to be then plus 5 kilograms times 0.5 meters. Now over the sum of all masses, that would be 2 kilograms plus 4 kilograms plus 5 kilograms. So in this case, then we have 2 kilogram times minus 1 meter, so that's minus 2 kilogram meters, plus 4 times 2, that's 8 kilogram meters, plus 5 times 0.5, that's 2.5 kilogram meters, over 11 kilograms. 2 plus 4 plus 5, 11. So that gives us minus 2 plus 8, that's 6. 6 plus 2.5, so 8.5 over 11. The kilograms cancel out, so meters. And so our answer is just 8.5 over 11, which is equal to 0.77 meters. So my center of mass, if I'm going to try to locate it here in this graph, our center of mass is going to be somewhere here. Now, just a simple question. We have a donut here. Where do you expect the center of mass to be located? I'm not sure if I call it breakfast champion, to be careful about how much sugar intake do we have and how much fat and everything. But anyway, is it on the outside edge, inside edge, midway, at center? There is no center of mass. Of course, it's going to be somewhere here, because I have as much mass in one end as to the other end, as much mass from one end to the other end. So this average position of these two is here. The average position of these two is here. The average position of these two is here. So this example illustrates the fact that the center of mass can sometimes be in a position where there is no mass.